Welcome to EDU World Space.
Hi, everybody. So we're on problem 12 in chapter 7 in an introduction to modern physics. So this question is asking, from the data given the text, determine the masses of the following stars. So we want to find the mass of A. Oh my gosh, the A is terrible, guys. Oh my gosh. A, we're just going to deal with that terrible A. 51 PEG. Okay. And then we have a B, which we'll get into in a minute. Okay. So you got to convert the orbital period of the planet around the star first. And from that, we have, if I get on the writing here, P equals 4.2 days. And we need to just convert that to seconds. And if we do that, it is 3.62880 seconds. You can literally just put this into the Google converter, or you can do the whole conversion yourself. You should be able to do that at this stage in your math career. Okay. And now we got to convert the semi-major axis AU to meters. So A equals 0.051 AU. And we'll add that. I'll do the conversion here because you might not be familiar with it, which is fine. You can also just convert it using Google. If that's 11, I don't know what I put you. Or your professor might give it to you to help you out, or your book. Okay, so this is 0.0765 times 10 to 11 meters. But I just did it for you, just so you know. Okay, so now we gotta do Kepler's law, which I feel like I never ever use Kepler's law. How it is written. I feel like physicists should just like move it around officially because I feel like you never use it how it is. We just basically want the mass to be on the other side. So we're just gonna move everything around. But I'm gonna say everything around. We're just gonna move like one thing around. There we go. Um, and then here you're just gonna plug and chug what you already have. So you have 4 pi squared 0.0765 times 10 to 11 meters cubed over gravitational constant 6.67 times 10 to the 11 meters cubed kilograms times seconds squared. And then we have our seconds, 0 seconds squared. You can go through and cancel these if you so desire. And then if you put that all into your calculator, you get 2.01 times 10 to 30 kilograms. Okay. We're not done because now we gotta actually compare the masses between this to the sun. So I guess it's PEG, right? Over M of the sun. What's about S for the sun? Some people do like a circle. Honestly, it's up to you what you like. Unless your professor really wants you to have something special. So we put the mass that we just have. The mass of the sun is 1.98 times 10 to 30 kilograms. Okay. And you can obviously see that that part kind of cancels each other out. So you're really just worrying about this, the math. And that becomes 0.99 to the mass of the sun. Okay. So now we have part B, which is wanting us to do the star HE 1684443C. And again, for that, we just got to convert its days into seconds. I'm not going to do that for you. I'm just going to write it out for you. If you need help, you can use Google. just because I feel like at this stage you should be able to know how to do this. And it saves us some time. Let's make sure you get this answer here. Okay, so now we do A with a semi-major axis, which is 2.87 AU. And I'll show you guys again, just so that way, this one you may not be familiar with, so I'll show you this one. Okay, there you go. Put it in your calculator. 4.305 times 10 to 11 meters. Okay. Now you're gonna basically use the exact same equation that I wrote. I'm not gonna write out Kepler's law and then switch around. We already did that right above. There's no need to do that again. Okay, so now you're just gonna plug and chug. 4 pi squared. Write your A, 4.305 times 10 to 11 meters over gravitational constant, 6.67 times negative 11 meters cubed, kilograms. Probably asking, do I have to write out all the units? Yes and no. If you like it, i.e. it helps you, then totally do it. Most professors want to see it, and you should write it all out for yourself so you can, again, this is huge here, so you can see if your units cross out, and my program is not cross out. Oh, I crossed that out. Oh my god. There you go. And it's squared right here. There we go. And it does help you, but sometimes when you're doing certain things that you already know the units, then you don't necessarily need to, but having the units allows you to see if you made any mistakes. Okay, you get 2.01 times 30 kilograms. And again, we're doing the exact same thing we did above, compare it with the sun. So HD over MS, you can use a different, you can use this sun symbol if you really want to. That's really up to you and up to what your professor likes, to be honest, on your homework or on the test. 30 kilograms. Now we're just focused on this. My calculator, get 1.01. Oh, okay, nice answer, guys. Thank you.